Okay, 2012 AMC. This was problem 20 from the AMC12A, and when I looked over the test, I didn't take the test, I'm a teacher, not a student, but when I looked over the test, I was so glad to see this problem. After those last couple problems with so much thought and effort going into them, this one's pretty easy. Okay, so it says, consider the polynomial p of x equals the product when k goes from 0 to 10 of x to the 2 to the k power plus 2 to the k. And they are even nice enough to give you what that looks like. And they want to find the coefficient of x to the 2012th. Okay, and it equals 2 to the a. They want to find a. So, for everyone on the video sake, if you need help on this, let me write out the actual terms of this polynomial, the factors of this polynomial. So, they start us off. Basically, we have all of the powers of 2 powers of x from 2 to the 0 up to 2 to the 10th, which is of course 1024, plus all the powers of 2. So the terms we have are x plus 1, x plus 2, x squared plus 2, go me, alright, x to the 4th plus 4, we have 11 of these, I hope I have room, but if not, I'll just sort of fill them in here and there. X to the 8th plus 8 times x to the 16th plus 16 times x to the 32nd. Let's see, I'm about halfway through. Plus 32 times x to the 64th plus 64 multiplied by x to the 128th plus 128 multiplied by x to the 256 plus 256. I'm going to have to go to the next line for the last two terms. Let me just stick them over here. Okay. Multiplied by x to the 512 plus 512 multiplied by x to the 1024 plus 1024. Okay, now polynomials, just so you know, basically what happens is any one of my terms is made up of the product of one of each of the terms from these factors. Okay, and especially since each of these powers are different. Now, something to notice is the only way I can get x to the 8th is with this. There's no other way to add up single units of these. So I can't multiply my way in any other way to x to the 8th than using this. So what this means is the only way to get to x to the 2012 is to use the powers of x that multiply 2012, and that will only happen one way. And so what's going to happen is, for 2012, I'm going to include 1024. Okay, so I'm going to include this term, and I'm going to subtract them because now I need to figure out what I need left. So 2012 minus 1024 should give me, what is that? Let's see, 988. Sure hope. Okay, and I can include x to the 512 because that's going to be less than 988. It goes into there, so 512. So that should give me, let's see, 476. I can include 256, and that will give me 220. I can include 128, and that will give me, okay, that'll give me 92. I can include 64. Let me bring this up here because I'm running out of room. So 92 minus 64 gives me 28. I can't include 32 because it's not is too big, so but I can include 16. So 28 minus 16 gives me 12. I can include 8 and I can include 4, but I'll do it one at a time. So minus that, minus 4. Okay. So basically, to get to 2012, the idea that I just said, x to the 4th times x to the 8th times x to the 16th times x to the 64th times x to the 128th times x to the 256 times x to the 512 times x to the 1024 will give me x to the 2012. They sure do love those years. The next thing to notice is, because of that, the coefficient on that will be made up of the factors that I didn't use. So I will use this 1, I will use this 2, because I can't use the x and the x squared to get to 2012. I won't use the 4, won't use the 8, won't use the 16, but I'll use the 32, and I won't use anything else. So the coefficient 2 to the a, that's what we're looking for, is going to equal 1 times 2 times 32, which is going to give me 2 to the a is equal to 64. And from that, of course, 2 to the sixth is 64. You could actually say a is the log base 6, log base 2 of 64, which is just 6. 2 to the 6th power 64. Answer is B.